All right, geometry, area and solids, area and volume test, review sheet. Number 3, what's the probability of a random point being picked inside the shaded region? So probability is just a ratio always, okay? So if it's numbers, if I'm picking red balls out of a hat, then they have red balls and blue balls in there, then we're gonna reach in there, and however many red balls there are to however many blue balls there are, or sorry, total balls there are, is gonna be the number of, or it's gonna be the probability of picking a red. Does that make sense? So same idea here. If we're gonna pick this area right here represents everything possible, okay? And just the shaded region is what we want to choose. So we're still gonna have just a ratio of shaded region, desired region, to total region, okay? So looking at this, just looking at the numbers, at the possibilities, does that look like 8% of that shape is shaded? Probably more, huh? 24%? Probably more than that. 29? Probably more than that. 80 or 84, you can't tell the difference between those two. Okay, but I'm looking for the shaded region. If somebody was saying this area, the inside, then I'd say, oh yeah, maybe. Okay, but we're trying to figure out the probability of the shaded region. So we're going to find out total area first. So this is a semicircle. So I'm going to take pi times radius squared. So the radius on this thing is 4. So that's 16 pi divided by 2. So radius squared times pi divided by 2 tells us the total area. Okay, that's the total area. Okay, and just the shaded region, just the shaded will be 16 pi over 2 minus, if that's a square here, this is just 2 by 2, so that's just 4, minus 4. So we want to get the decimal approximation for both of those there. So 8 pi, so we got 8 pi for the total. So this is like 25.133, and this over here is going to be that number minus 4, so 21.133. And if I take those two and divide them, I get 84, I get 0.84. So if I go shaded divided by total, I'll get the probability. So that's going to be 84, it comes out to be. So that was number 3 on the area and volume review sheet. Other questions? Which one? Can we do number 2? Sure. Go up to number 2. Yeah, this one requires you to do a polygon, a hex, or a pentagon that. I'm gonna make this bigger so I can draw in it. All right. So shaded region here, shaded region is going to be based on the area of the circle and the area of the pentagon. So we're going to do the pentagon first. So the pentagon, we're not even going to see it as a pentagon. We're going to see it as 5 triangles. And each one of those triangles is isosceles. And one of those triangles, or all of those triangles, have a height of 16. 1/6 right there. Also, all of those triangles have a total top angle of 72, right? 360 divided by 5. That's right. Thanks. Bye-bye. Skylar, you ready to go in the office? Okay. The top, so if I take 360 divided by 5, oh, we even know this 23 point, I didn't see this. We know that's 23.2. So then this right here is 23.2. 2. All right. Let's say we didn't have that. They didn't have to give that to us. Okay. We could have just used the angle. That angle right there, this total angle is 72 degrees. 360 divided by 5. And then we could cut that in half and say that this angle right here is 36 degrees. And we're going to need that a little bit anyway. But that half angle, this angle right here, is 36 degrees. Then we could use trig to figure out using tangent. We could use tangent is equal to opposite over 16, multiply both sides by 16, so tangent of 36 times 16 is 23.2. Let's just check that in the calculator, make sure that is the case. 16 tangent of 72. See, I got 49.24, but I know what happened. I'm in degree mode. I'm in radian mode. I'm in degree mode. All right, so that is not the tangent of 72, it's the tangent of 36. So tangent of 36 is equal to x over 16. So that's how we would have found x if we needed to, and that came out to be 11.62, which if you double it gets 23.2. All right, so moving on, we can find the area of this triangle because we have the base and the height. So we have 1/2 times the base, 23.2, times the height, which is 16. And then whatever answer I get there, I'm going to multiply by 5, because there's 5 of those triangles. Remember, there's regular polygons are just triangles all the time. So times 0.5 times 16, and then 185 for one of them, so times 5 is 929. So this is 929.97. That's what we got there. All right, so let's make room now. So now this triangle also, this isosceles triangle also is going to help us find the radius of the circle. This is 16. Remember, this half is 36 degrees. This is the radius of the circle. This side right there is the radius of the circle. So we're going to use trig to figure that out for r. So that's the adjacent, that's the hypotenuse, so we're going to use cosine. Cosine of 36 degrees is equal to 16 over r, multiply the r up, r cosine of 36 equals 16, divide by the cosine over, r equals 16 divided by cosine of 36. So that r is 16 divided by cosine of 36. We get 19.77. That's my radius. But now I have to square that and multiply it by pi to figure out the area of the circle. So square it and multiply it by pi, and we get total, we get 1228.78, and this is centimeters squared. This is centimeters squared. So I got to subtract that off. I got to take the number I just got minus the 929. Minus 929.97. Did I do that right? 298. So the closest one I got here is 299. So, A. So those regular polygons, they're just triangles. All you got to do is figure out the triangles on them. All right.